Hello everyone, welcome back to the channel. In this video, we will be discussing about the third problem of today's bi-weekly contest, minimum sum of squared differences. Problem states that you are given two array nums1 and nums2, both of length n, and you can perform some operations like you can either add one or subtract one from any elements of nums1 at most k1 number of times. Similarly, you can add one or subtract one from nums2 at most k2 numbers of time. Now you have to perform this k1 and k2 operations such that the sum of squared differences is minimized. So, for example, if let's say k1 is 1 and k2 is 1, basically you can either add or subtract to any elements of nums1 at most one time, and you can add or subtract to any elements of nums2 at most one time. So what is one possible solution? One possible solution is just add +1 to the first element of nums1 and k1 will be exhausted, and increment the third element of nums2 by 1 and k2 will be exhausted. So your new array will become 2, 4, 10, 12, and 5, 8, 7, and 9. Now, if you calculate the sum of squared differences, you will be getting 43, and you can, like, it is guaranteed that if you apply this operation on any of these other elements or any of these other elements, the sum of squared differences will not be smaller than 43. Hence, 43 is the answer. So now how to solve this? So first thing to think about in this problem is what happens when, like, we have to perform this operation, right? Either +1 or -1 on any index, like on any index of nums1 or on any index of nums2. So first let's see if we apply this operation on nums1 on the index I of nums1 or nums2, what happens? So basically what we want to do, this is the final output from the ith index, right? Nums1 at I minus nums2 at I to the power 2. So this is the contribution of the index I, and we want entire sum to be minimized, right? So that's where our goal is to make the difference as less as possible, right? So for a single index I, every time our goal is to make the difference as less as possible, like this absolute difference as less as possible. Now let's say we have to apply, like we are using k1. Okay, so k1 means that we have to apply the operation on nums1. Now how you will apply an operation on nums1? Let's say you have to apply one operation. So let's say nums1, like, remember your goal is to minimize the difference. Now let's say nums1 at I is less than nums2 at I, then you have to minimize the difference. So to minimize the difference, what you can do is increment nums1, right? So that is like you perform one operation on nums1 and you actually minimize the difference. Now similarly, if nums1 is greater than nums2 of I, you can simply subtract 1 from the first, like nums1, and you will minimize the difference. And if they are equal, you don't need to do anything. Like, remember that you are given that you have to perform this at most. It may happen that you may not perform any operation. So in case you have to apply an operation on nums1, you can always decrement the difference by 1, right? You can always do that, if even if nums1 is less than or even if nums1 is greater than. If they are equal, anyway the difference is 0. You don't need to do anything. Similarly, when you have to apply operation on nums2, okay, so basically you are applying operation k2. So what you will do, let's say nums1 is less than nums2 and you have to apply on nums2. So you can simply subtract 1 from nums2 and difference will be decreased. Similarly, if nums1 is greater than nums2, you can simply add 1 to nums2 and your difference will decrease. So what, in a way, what we are saying is, no matter what is the condition, if you apply one operation on nums1, you can always decrement the difference by at least 1. Similarly, no matter what you did, like, you can always do something and decrement the difference by 1 by applying an operation on nums2. So in a way, what we are saying is, No matter we apply a operation on nums1 or nums2, in a single operation, we can always decrement the difference by 1. So either we can apply an operation on nums1 or we can apply an operation on nums2, and we can guarantee that we will be able to decrement the difference by 1. Decrementing is our goal, and in one operation we can decrement it at max one time. So irrespective of whether we are applying it on nums1 or nums2, we are always be able to decrement the answer by 1, or the difference by 1. So hope this point makes sense. So this point actually states that applying operation on nums1 or nums2 doesn't matter. You can apply on either of them, it is fine, right? So we will look at it again with an example, but let's move forward. So what's the next question? The next question is, we understand what happens when we apply an operation on a single index. Now which index should we apply the operation on? So let's say, like, finally we have this sum, right? A1 square plus A2 square plus dot 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 up to an square. Now we have to decrement this entire sum. Let's say for simplicity there are two elements only, A1 and A2, and we want to just decrement this sum. So in one operation, we just saw that we can decrement this sum by 1, right? So we can either decrement A1 by 1 or we can decrement A2 by 1. Now which one to decrement? Let's say we decrement A1 by 1, then the final sum would be something like this. And now let's say if we decrement A2 by 1, then final sum would look something like this. Now notice that this two piece is actually common, so it doesn't matter. Let's not worry about this. Only difference between these two are this thing, and remember that they are with negative sign. So now let's say A1 is greater than A2. Okay, so if A1 is greater than A2, which one will you prefer? Will you prefer decrementing A1 or will you prefer decrementing A2? So if A1 is greater than A2, the total sum is greater for this piece because we are decrementing more in this particular case, right? In first case, we are decrementing more. But if we apply the operation on A2 and if A1 is greater than A2, then we will be decrementing, but this difference will be larger. Like this is larger than this. This entire piece is larger than this piece. So hence, it actually shows that we will always apply the operation on the index which have greater difference. Because if we apply the operation on the index which have lesser difference, the total sum, the final sum would be actually greater if we would have applied the operation on the element which has larger value. So hope this point makes sense. So what we get out from here is we will always decrease the one with the highest value, right? Now let's just move forward. So what we have just figured out is we will always decrease the element with highest value. So what we need is we need a data structure that can actually find the maximum element, like difference. Like we want, let's say the difference, let's say the array is 4, 5, 6, 7, and nums2 is 0, 3, and 3 and 6. Okay, so what we want is we will just calculate the differences 4, 2, 3, and 1. Now once we have differences, we can just use this array to find out our answer. So in a, like we have just discussed some time back, that we can always decrement 1 from this difference irrespective of whether we apply operation on nums1 or nums2, right? Then we discussed that, okay, we will apply the operation on the number which have the highest value. Now what we actually want is we want a data set that can actually find the maximum efficiently, because we want to apply the operation on maximum value, right? And we have to remove this maximum element from this from this set, because once we have applied the operation on maximum element, we don't like this element will be decremented by 1. So let's say we apply the operation on 4, this 4 will become 3. So what we want is remove 4 from our set and add back 3 in our set, right? So that's why we can remove the maximum efficiently, and we can insert a value efficiently. So this is nothing but a priority queue, right? So priority queue or a heap, like just same thing. So what we can do is we can just maintain a heap of maximum differences, and we can just calculate, like we can just pop the topmost element, decrement it, and push it back to the array set. So in a way, that's just what happens on this kind of array is, this is the initial array. We apply the first operation. We pop 4, decrement it by 1, and push back it again. So there are 3, 3, 2, 1. Now we again pop the largest element, decrement it to 2. Now the array becomes 3, 2, 2, 1. Again we pop the largest element, decrement it by 1. Now this one, and so on and so forth, right? So what we are doing is we are just popping the largest element, decrementing it by 1, and then again pushing it back. So what will be the time complexity of this entire solution? Time complexity would be, like, remember, when how long we will keep on doing this until there are some element in the heap. Let's say after this step, this one will become 0, right? So you don't need to push 0 again, because this is 0. It means the difference is 0. So this is not contributing anything to the answer, and that's the best piece. So once it is 0, we will remove it, and the next set will become 1, 1, 1. Only 3 elements. Similarly, the largest is 1. You will remove 1. It will become 0, and next set will contain only 2 elements. So in a way, we will keep on doing this until there is an element in the heap, right? So how long there will be an element in the heap? Let's say initially 4, 4, 3, 2, 1 was the set, right? So this 4 can be decremented 4 times, this 3 can be decremented 3 times, similarly this 2 can be decremented 2 times. So in a way, total number of operation that we will be doing is 4 plus 3 plus 2 plus 1, right? Sum of the entire differences, right? So let's just look at the constraint. The constraint is nums1 and nums2 of I is less than equal to 10 to the power 5. So what will be the difference between nums2 and nums2 of I and nums1 of I? The maximum difference is 10 to the power 5. Like, let's say nums1 is 0 and nums2 is 10 to the power 5. So maximum difference is 10 to the power 5. So there will be 10 to the power 5 number. How many times? The length of the array, which is 10 to the power 5. So there will be 10 to the power 5, 10 to the power 5 number of times. So what will be the sum? Sum will be 10 to the power 10, right? So this will be the time complexity. But this will surely not fit in the time constant. So we can't use this heap solution. But we know that this is correct, because we have proved that we will always, like, it is always efficient to decrement the one with the highest value. So now we have to, like, apply this solution only, but we can't use heap. So what to do? Notice that we, like, we are doing same operation multiple times. So let's say there are 3 twos, right? If there are 3 twos, will we ever apply any operation on 1 until these 3 twos are converted to 1? The answer is no. Basically, unless and until all the 3 twos are converted to 1, we will never pick this 1. So in a way, what we can do, we can group these 3 2, and we can say that there are 2 3 number of times, right? So now when we apply operation, we can simply say that if we see 2 and it is 3 times, we can simply apply 3 operation at once. Instead of applying 1 operation, we can simply apply 3 operation at once, and just decrement this 2 to 1, like all the 3 twos to 1 in a single iteration, right? So that's the entire idea. Basically, we want to group the operation so that we don't need to perform this 10 to the power 10 number of operations in the first place. So let's see how we'll do that. So again, just to mention it again, we will never touch x minus 1 until there is x in our array. So we can group all the values of all the values with x in a single group. So let's just take this again. Okay, now what to do, like we can yeah. So what we can do is, instead of saying that, like currently there is 1 4, right? So what we can do, what we can say that, okay, decrement this 1 4 to 1 3, and there will be one operation. Now there are three, let's just prepare another array. Okay, so let's say this is array. This is index 1, 2, 3, and 4. Now initially everything is 1. There is 1 1, there is 1 2, there is 1 3, there is 1 4. Now we apply one, like we are currently at 4. So what we will do, we will simply say that, okay, apply this many number of operation and convert all the 4s to 3. So basically now after applying one operation, we have converted all these 4 to 3. So there are now two threes in our array. Now once 4 is completed, we will move to next element, which is 3. Now again we will say that, okay, there are two elements which have value 3. Apply two operation and convert all these 3 to 2. Now there are three number of 2's. Okay, now we will again say, okay, there are three elements with value 2. Apply 3 operation, and we we can say that after applying 3 operation, there will be 4 ones. So notice that how we are quickly applying operation. Previously, to reach 1 1 1 1, we need this many iterations, but now we reach all the 4, like 1 1 1 1, like this actually denotes the same case, 1 1 1 1. We only need 3 iterations. So that's the power, like we are actually never visiting the next element again. We are just starting from the topmost and going backwards one by one after decrementing every element. So hope this solution now makes sense. Let's just look at finally what will be the time complexity. So what we are actually doing, we are preparing an array. Let's say the maximum value is m. So what we are doing is we are preparing an array of value m, where each element denotes that how many times this particular, like, ith element denotes that how many times I appears in our array. Okay, now we are starting from the topmost element, and every time we are just decrementing it by one place, right? So in a way, our time complexity is order m, where m is the maximum value of the difference. And what is the maximum value of difference? Maximum value of difference is 10 to the power 5 in our current problem. So hope you got the solution. Now what will be the, this is the final pseudocode for our solution. So let's just quickly look at it. So we first make the array count. Okay, how to make this array count? This count of I basically denotes the number of indices with difference I. Now once you have array count, and remember in the very first slide we have discussed that we can actually apply operation on either of the nums1 or nums2, it doesn't matter. So that's where, like, we have just merged these two operations into a single operation. Now we will start from the topmost and go until 1. So what is n? N is not the length of the array, n is the maximum difference. Like basically what we have discussed as m is currently m. Now what we will look at is if there are more elements than operations allowed. Let's say that we are only allowed 4 operation, but there are 5 ones. Let's say there are 5 ones, and we are only allowed to have 4 operation. So what we can do, we can at max just make all 4 ones to 0, and 1 will remain, right? So that's what we are doing. We are decrementing count of I by this thing. Basically initially it was 5, now we are decrementing it by 4 to suggest that there is only one I that will be remaining and will break, because we are sure that operation is now 0. We can't apply any operation. Otherwise, we can increment, like let's say there are like 3 ones, okay, and there are 5 operations which are left with you. So what you can do, you can actually, or let's say there are 3 twos, okay, and there are 5 number of operations that you can do. So what you can do is you can convert all these 3 2 into 1, and you will be spending 3 operation for this. So what you're doing is number of operation is reduced by 3. So that's what we are doing. Number of operations is reduced by count of I, and count of I minus 1, like number of ones, is now incremented by number of twos, right? So similar, like we just incremented count of I by count of 1, the count of I minus 1 by count of I. So after this loop ends, so CNT of I, count of I will contain how many indices are there which have differences I. So we can just do summation of I square into count of I. That will be our answer, right? So hope this entire solution makes sense. Again, just to reiterate, we make the array. After making the array, we saw that we, like, both the operation can be combined, because it doesn't matter whether you are applying the operation on nums1 or nums2, and you will be starting from the maximum element, because we just discussed a while back in this particular slide that it is always optimal to apply the operation on the bigger element. So that's where you will start from the topmost element. Okay, and now if you can, like, you are just starting from the topmost element and just grouping all the numbers which have this particular value, and just converting it to m minus 1, like basically the previous value, or by spending some operations. And if operations allowed is 0, you will just break out from the loop, and finally this you will output this, because count of I denotes how many differences are there with value I. So there are, like, let's say, three numbers which have difference I. So what you will be getting as the answer is I square plus I square plus I square. So that's where we are just uh, summing up all I square into count of I. So let's just quickly look at the code. The code is very simple. We make the array count as we discussed. So n is 10 to the power 5 in that is given in our case. So we just make the initial count array. After that, we make this operations variable. Now if count is 0, like basically there is no element which have this particular value, we just continue. Otherwise, what we have just discussed is something that we have done. We have if operations is greater than count of diff, basically there are more operations allowed than current number of twos or current number of i's. So we can convert all the I to I minus 1. So that's where we have added all the CNT of diff to CNT of diff minus 1. So, and after that we will, like, for doing this we will be requiring this many number of operations. So we just decremented our operations by this, and because we have converted all of them to diff minus 1, so diff is becomes 0. Otherwise, if operation is less than, there are more elements than the number of operation, you can't convert everything to the previous element. So you just convert whatever you can, basically the number of operations that you have, and you just decrement the current with this particular operations, and finally break from the loop. And after this, you can just you are just doing this j square into CNT of j. So hope this solution is clear. If you have any doubts in this question, please post them in the comment section below. I would be happy to answer. I will see you in the next video. Thank you.